Hey everybody, this is TCG Productions here, and today, if you couldn't guess by the video title, we are going to be doing, well, more stuff with the file server. Yes, this is Fileserver Fiasco 3. If I remember correctly, Fileserver Fiasco 1 was upgrading from a 640 gig drive, either that or 2 terabytes, up to a 4 terabyte drive. Fileserver Fiasco 2 was a move to from 4 to 8 terabytes. And this one's going to be a little bit different because we're not going from 8 to 16 terabytes or 18 terabytes or 22 terabytes. We're not doing that just yet. That will probably be a Fileserver Fiasco 4 or 5. Got a whole series going on this now at this point. Once is coincidence, twice is once is happenstance, twice is coincidence, 3 times is enemy action, and 4 times is official gnome policy. Anyways, digression. So today, or well, at least in this video that you're watching today, whenever today might just so happen to be, we are going to be making some pretty significant changes to the file server. And these changes involve not only splitting up the boot and the data partition, specifically, well, actually we're going to be splitting them up onto different drives. So the file server will boot from one drive, but all the data is going to be on everything else. So, and also going to be doing a major file system conversion. So we are going to be going from ext4 for everything to a kind of a three-way combination. ext4 for the boot drive, ZFS for the data drives, and that is ZFS with not only deduplication, but also online deduplication, also online compression, and the and I believe we're also going to store the intent log separately, and we're also going to have a write cache. So, lots of stuff going on there, and the backup drives are being converted to BTRFS with online compression and offline deduplication. So, lots of stuff happening here. I've already got the file server shut down and pulled out of its cubbyhole, and actually opened up here on the table while I was doing some pretty quick precursory inspections to determine just how much of a pain in the butt this is going to be. And I was pleasantly surprised to find that this system is one of the few that I have that actually has a full 6 serial ATA ports on it. So, and I also made an unfortunate discovery. This motherboard is affected by bad capacitors. So let's cover a couple of these. Let's cover these two items real quick. Down here we have 6 serial ATA ports. 3 of them are in use. We've got 2 hard drives and the optical drive on them. And then we have a couple of empty ones there, as well as an empty one right there. You can see it in the middle of your screen. And then for the bad news, we have a bad capacitor right here. I don't know if you can tell or not, but the top of this is domed. It is bloated. It is coming up off the board, and there's a little speck of dried electrolyte on that capacitor. Some of these capacitors also show signs, such as the one right here by this model designation. This has some crud on the top of it. Does not appear that it has completely vented, but I cannot get it to sit level on the motherboard. So that tells me that the rubber bung at the bottom of that capacitor has probably blown out. And we have I can tell you right now just by the color, that's a TPO, or at least a clone of it, that is not quite sitting level. There's a couple more up there that aren't sitting level. So sometime late this year, early next year, this system is going to have to get its motherboard yanked out for a recap. So I don't do those myself. I send these off to someone else that does that sort of thing. And that is the end of that. So, So yeah, there is that. So that is definitely a bit of an unfortunate discovery, but rather find it now when the system is good and stable than later when the system isn't stable and I'm trying to figure out what's going on. But then again, our utility power plus plus the condition power coming out of the UPS is in here. There's a Eaton PowerWare 9130 way off over there, as well as an APC Smart UPS SMT 1000 right there. Good utility power plus good condition power means that even systems with shall we say dire straits happening in the capacitance department are still abnormally stable, if that makes any sense. So, and these systems do run hot. Like there's 3 systems packed in pretty tight right in here like sardines under the desk. There's a little small form factor Dell on top of them as well. And so yeah, these things run hot, and before I really start tearing in anything, I'm going to tear into something. I'm actually going to take the power supply out of this system, open it up and inspect it. And that also brings to mind powering our soon to be added hardware. Yes, we have new hardware that's going to be going in here. We have not one but 2 Western Digital 480 gigabyte Easy Store SSDs that a friend was nice enough to give me. So thank you very much for that. And so we are going to need 2 available serial ATA ports, serial ATA power connectors to make that happen, or at least something that we can sufficiently adapt to make it a serial ATA power connector. And trust me, I've got plenty of stuff around here to hack a serial ATA connector onto something. Even if it is going to be a complete and total pain to get to, because this tech room is presently a bit of a mess. Yes, there was a sizable warning about that at the beginning of the video. No, I don't need to hear about it, and yes, I will delete your comments if you do just so happen to comment on it. Repeated comments or excessively rude comments about that matter will get you banned from commenting on my YouTube channel. Thank you very much. So anyways, I can wrap that around. Isn't that clever? Yeah, so that matter is not open for any further discussion. Thank you very much. So, anyways, okay, there we go. Now for my next trick, I'll see if I can scare up a Torx T15 driver. Let me see, 15. Because HP took a page out of Compact's book and used Torx screws on their systems. This is not... Like, Compact did this back in the 1990s, and HP, even after they bought Compact, didn't immediately do this, but sometime in the late 2000s, whenever they introduced this particular case style, that's when they started doing that, and that's when they started driving me up the wall, because then that means I have to go get special tools. So, anyways, power supply is out of the system. Just gonna set this off to the side, hopefully with relatively little fanfare. So now what I'm going to do is I'm actually going to go ahead and pop the cover off of this power supply and see how we're looking in here. Because if I need to, if this power supply is suffering similar problems as the rest of the system, well, as the motherboard at least, I need to know about that and kind of see what the status is on it, if I can get away with leaving it in service temporarily until I can get around to getting this thing recapped. Or if this is one of those things where I just need to go ahead and swap in a new power supply immediately. Well, not new, but good enough. Swap in a good power supply immediately. I mean, it is a light-on supply, so definitely a pretty high-quality unit. Okay, this is going to be a little bit difficult because I believe this has a PFC choke on it. Yes, it does. So that makes things slightly interesting. Okay, there we go. And just looking at it, I don't see anything that immediately comprises the word problem. I do see some glue that I do see some white glue that is beginning to turn tan colored. So I'll need to pull this thing apart at some point down the road, and I'll definitely need to pull this power supply apart at some point down the road and get this tan glue out of here. Because what happens is this glue starts out white and compliant, but over time it turns tan and eventually turns like brown. And as it does so, it also turns conductive, which is a very bad thing in electrical power supplies, because things turning conductive that don't need to be conductive is how things go, shall we say, boom, bang, crack, snap, crack, snapple, pop. What am I trying to say? Okay. Now, snap, crackle, pop, Rice Krispies. So, okay, so the power supply is for the time being okay. However, its cover does not let me go back on very well, and I think I know why. Because it has these tabs that are intended to lock into screw holes, but this back cover has gone somewhat cattywampus on us. Okay. There we go. So this power supply is going to be okay for the time being, but it will require attention sooner rather than later. And I might as well do that while I've got the motherboard out of the file server for recapping. So, and I'm not sure if you've noticed or not, but I've got the 1993 Gateway 2000 80486 system up and running. I've been messing around with it the last couple days. So, also got the Dell Dimension 2400 up and running, if you couldn't tell. Had to copy some files from a USB drive onto a floppy diskette. And that is the easiest to use system that I've got that has both USB ports and a floppy diskette drive. So, and I think while we're in here, I'm just going to go ahead and delete the optical drive. And to get rid of the optical drive, I have to take the front of the case off because, well, this is an HP system I'm working with. Comes off, and then that comes out, and now I have a spare serial ATA optical drive. Leaves a set of power and data cable free for anything else I might want to use it for. Get this power supply put back in here. Okay, we are back. I ended up turning the power supply over and navigating to the system that way. And as you might be able to tell, I have actually gone ahead and cabled up the SSDs. They're plugged into both power and data. So I'm not actually going to go ahead and install what will eventually become the new boot drive just yet. So I think at this point we can safely go ahead, put the cover back on here, and get this thing cubby holed up. And if we can get the cover to go back on, that's our next big trick. The system was actually dropped at some point in its past, and that has tweaked the case geometry by, well, a bit, so to speak. Anyways, now it's time to go ahead and get this thing cubby holed back up, and we will come back once we've got the system up and running and we have access to a terminal, so that way we can continue our ZFS configuration. And on today's episode of I Completely Forgot This Even Existed, I completely forgot about the fact that the Intel ICH9R chipset that's in the file server actually has a built-in RAID controller. Yes, I kid you not. This has an actual built-in RAID controller. I don't know exactly what RAID types this supports, but for our purposes, we're going to be using a RAID 1. We're going to put the two SSDs into a RAID 1 array. And I don't know if the controller itself has its own hardware accelerator or whatnot for RAID and for RAID and everything to do with that, or if it just dumps that onto the system's CPU and says go fish. So anyways, as you can see here, the 4 and 8 terabyte drives are the top two disks listed here, and it's obviously not quite detecting those drive sizes correctly because, well, they're big drives, but the SSDs are being detected correctly. So we're going to take option 1 here, create a RAID volume. Let me see, name. Let me see, ZFS. ZFS special here, because these will be special. This will be a special VDEV. 16 characters or less. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's right. Tab. Next option. RAID 0. Oh, God. Okay, let's see. ZFS Special. Okay, it looks like this only supports RAID 0 and RAID 1. RAID 0. How do you select? Okay, yeah, this only supports RAID 0 and RAID 1. So we'll be selecting RAID 1 since we only have 2 drives here. RAID 1, I'm getting all sorts of crap confused. Select disks. And of course we will use the space. Western Digital Easy Store SSDs. 480 gigabytes. And we'll go ahead and use the full capacity here. And let's create. Warning, all data on selected disks will be lost. Not like there's any data to lose anyways, because I've already hit them with an ATA security race. Yes. And there we go. ZFS Special RAID 1 mirror. No stripe size because it's a mirror. 447.1 gigabytes. Status normal, and it lists as bootable. So we'll just go ahead and back out of here. Do you want to exit? Yes. And I'm actually going to go ahead and reset the system here. I think it actually has a pretty quick post on it. Everything looks good. That was quick. Has a Q8300 Core 2 quad processor at 2.5 gigahertz. Post beeps. And let's go ahead and boot up. Failed to start import ZFS pools by cache file. Okay. Yeah, the kernel does not boot verbose. So, and I'm pretty sure it has other methods of importing a ZFS pool anyways. So, we are going to come back whenever we actually have a terminal and preferably some screen recording software and a microphone. Unfortunately, my only good webcam with a microphone is all the way over there, buried in that hoard of stuff. So, yeah, it might be just a tad before we come back. So anyways. Okay, everybody, we are back. I got a little bit ahead of myself there. So, anyways, what I've gone and done is I've actually went ahead and configured the SSDs, got them put together into an MDADM RAID 1, and I figured out how I want to split up the space on the SSDs. I'm going to have a 10 gig partition. I'm going to have two 10 gigabyte volumes on them, one for each of the ZFS pools. Well, I've got a 10 gig for the 4 terabyte drive, and I'll probably do a 20 or a 40 gig for the 8 terabyte drive that's in this system. And I've also gone ahead and installed what will become the boot drive. That is a 160 gig Western Digital Scorpio Blue drive, a 2.5 inch laptop drive I pulled out of something ages and ages ago. I think it was an Acer. I think it was an Acer netbook, an Acer Aspire D110 netbook, if I remember correctly, or a D550 netbook, or something like that. Anyways, now what I need to do is I need to actually go ahead and prepare to split up the boot and the data partitions. And splitting that up is going to involve actually deleting all of the data on the 8 TB drive where the system is currently booting, so I can shrink the ext4 partition down, and then we'll use Clonezilla and clone that over to the 160 gig Western Digital Scorpio drive. So anyways, I'm not recording the bottom of the screen apparently. There we go. So anyways, first thing I'm going to do is just issue a dfh command. I hope you can read that. If you can't read that, let me see, we have a dedicated boot partition. Okay, that might present some interesting challenges. Okay, anyways, I might just do a drive-to-drive clone. That might be easier. Anyways, what we've got going on here is devsda1 is our boot partition. That's an 8.6 gig partition, 84 megabytes in use. Well, it's a 9.1 gigabyte partition with 84 megabytes in use, 8.6 gigs free. And then the big 8 terabyte data drive is it's 66% in use. So Linux is using 1024 megabytes. Drive manufacturers obviously use 1000 gigabytes, so it's so it's kind of a mixed up world out there. So anyways, Linux is reporting 6.9 terabytes total, 4.3 terabytes in use, 2.2 terabytes free, for 66% of the drive being in use. So I'm just going to do a quick directory listing here, and then I'm actually going to have to RMRF everything. Everything in the various server shares, various file shares. I've already gone ahead and backed everything up, and the drives are actually completely disconnected, so there's no way I can accidentally erase those. So and I believe, yep, there it is. That is the family file share. So now for the really scary part. RMRF everything in the current directory. And now we wait. So what's going to happen after this is we're going to go ahead and shrink the ext4 partition down and clone everything on the drive, well, everything that's left on the drive, over to the 160 gigabyte drive, and then we'll make sure that the file server can boot from it, and then we'll go ahead and wipe out what's left on the 8 terabyte drive. And then after that's all said and done, we'll go ahead and steamroll a new ZFS pool down on it and get everything set up for that. So anyways, let me see, dfh, let me see, we were at 4.3 terabytes at 66%, 4.2 terabytes 65%. So now let me see, CH15, no, not that, SHS. Nothing in here because that directory is actually no longer being shared. Okay, bash history, bash logout, bash rc, cache config. Nothing in there, that's good. 3 local Let's just check something in here. 120K in my own home folder. Normally this would be a whole lot bigger because DD3 would actually be traversing onto the 4TB drive, but that 4TB drive is currently unmounted, so see what's in here. 66 megabytes. Yeah, so that leaves the bulk of the drive space usage in this one folder. So now again for the really scary and teeth bitey and all that kind of stuff part. So RM, RF, and the reason I'm using ./* instead of just asterisk is because I absolutely do not want this RMRF command traversing out of the current directory, because if that happens, it's just going to wipe the entire system out, and that would be no bueno. So we're going to go RMRF, and then dot is a reference to the current directory, / indicates that we are going to specify a subdirectory or a file or something, and then an asterisk is just a wildcard, everything in here. So that will limit the deletion to the current directory, provided there's not some massive breaking bug in the RM command. So, and before we do that, actually, let's start up Tmux here, divide this into a couple of panes. Kill window bash, no. Divide this into a couple of panes. And we'll go what DFH, and then RMRF. Can't see because I've got all the lights off in here so the camera can see the screen. This is why I need to do screen recording instead, but the camera, my webcam with an actually good microphone, is all the way wedged in a very odd corner of this room, and it's going to be a complete pain to get to. So this will do for now. So RMRF, everything in the current directory, go. Okay, we are back, and this is a really nice thing about having like a bunch of computers and stuff with lights and whatnot in here, because you can turn them on and you get more ambient light without actually having to turn on the big lamps that produce lots of light, especially when you don't need lots of light, such as whenever you're recording a monitor. So anyways, as you can obviously see, the RMRF command has completed, and we are now using a nice and clean 4 gigabytes worth of space on our boot drive. So now what we're going to do is I'm just going to get out of here, and we're going to reboot the system. And if I remember the key to get into the boot menu, I think it's escape or F12. It's one of those two. Yeah, F12 for Dells. I believe it's escape for older HP systems. But we are going to boot into a Kdenlive. We're going to boot into a Kdenlive system on a USB flash drive that I've got. And from there we are going to start up Gparted, and we're going to do a couple of things. There we go. Oh, that is full. That's normal. No, that actually is normal. Debian GNU Linux Live. And I'm going to turn the exposure down. And yeah, we're gonna boot up into Debian GNU Linux Live, and from there I'm going to install gparted if it's not already on here, and then we're actually going to go ahead and resize the ext4 partition down to 160 gigabytes, give or take swap space. I don't even know if I have swap configured on here. I don't think I do. And XFCE4 is coming up quite nicely. I like XFCE4. And as soon as this thing gets its brains put back together, we'll be off to the races. I mean, we've got two XFCE4 panels here, and that's it. We don't have a mouse cursor, don't have a background yet, or anything like that. But what we do have is a local college-run radio station with some jazz music. And an activity light on the flash drive that is just going at it. Okay. 8 terabyte volume. So let's see. Is gparted on here? That would be under system. Gparted does not appear to be on here. Sudo app gparted. Let's update our package repositories real quick. Gopher. And of course, this isn't actually installing it directly to the flash drive, since this is all going into a this is all getting dumped into a RAM disk that's going to be erased whenever we shut the system down. There we go, gparted. Drives just disappeared because gparted. First thing it does, you could use an extra 5,808 blocks. No, thank you. Basically, what happens is gparted. First thing it does is it actually goes ahead and locks all drives for itself. So that way nothing else can access them. So as you can see, we've got quite a few things happening here, but let me see. DevSDF is our Western Digital Scorpio Blue. DevSDE is our flash drive. SDC and SDD are our SSDs. DevSDB is the 4 terabyte drive, and DevSDA is the big 8 terabyte data drive. So we'll right click on this big partition here, and I do not have swap configured. And what we'll do is we'll just drag this way down, and about 76 gigabytes is good. Should be able to clone over with that. And we'll go ahead and resize it. Now we have a very large block of unallocated space, which is fine. And go ahead and apply all operations and hope that this thing doesn't absolutely explode into 6-foot flames. Yes, I wish to continue. And we're gonna do a file system check. Force yes, verbose. Checking inodes, blocks, and sizes. Over here. Checking directory structure, directory connectivity. Thankfully, there's not a lot of data for it to have to go through, or else this would take a significant bit of time. Checking reference counts and Let's clear off the right edge. Then again, it's kind of also dealing with the aftermath of a file system that used to be 66% full. So, there we go. Just expand that out. There we go. Resize 2FS. Shrink file system. Resize. Well, that's happening. Let's see. No bad blocks. One large file. Very few non-contiguous files and directories. And no, it is not actually 3:56 a.m. The clock is incorrect. What time it actually is 9:55 p.m. and change. But well, that's what the clock on the far end of the tech room says. Yeah, that's what the clock on the far end of the tech room says. Okay, it just rolled over to 9:56. But since this system is probably much more accurate than that clock, since not only is this system getting its time from an internet time server, but that other clock is being powered by a double conversion uninterruptible power supply, and I've seen the line frequency on those do some funny things from time to time. Okay, blocks. Okay, that took a grand total of about 8 minutes, 10 seconds. So, nothing's obviously exploded. So, go ahead and close that. Ignore, and close that. There we go. 80 gigabyte volume. Well, it doesn't look like anything's exploded. And why are these showing as... what is these? Access denied? Yep, okay. For some reason, I thought these were showing as broken sim links, because that would have been very bad news. Home, Drifton, access denied. Drive isn't mounted. That's a, let me see, test.tax is blank. Okay, here everything appears to be working here, so we'll just unmount that, and now we'll shut this thing down, and now I'll go ahead and get Clonezilla written to this thumb drive, and we'll be back shortly. Okay, just got Clonezilla written to my thumb drive. Now we are going to power up. At some point we should get a boot menu. And there we go. SanDisk Cruiser Glide. Okay, let's go. Other modes. Kernel mode setting with large font and 2 RAM. You also know the display is kind of blown out. Probably turn the exposure down from where we get into a menu. I know once the console font changes, I can yank the flash drive, since I chose the 2 RAM option. There we go, that's nice and readable. And then we get small fonts again. Okay, English, default keyboard layout. Oh, there we go. Start Clonezilla. And let's go device to device. Export mode, local disk to local disk. 5 hard disks, it says. Which makes sense. Got the 8TB drive, 4TB drive, both SSDs and the 160 gigs. So we'll choose the 8TB drive as a source disk. And we're going to select the 160 gig as the target disk. Okay. Continue. We just checked and repaired the source file system. You know what? I haven't ever done this before. Let's go ahead and interact. Let's just do an interactive check and repair. We're going to use the partition table from the source disk. Choose when everything's done and continue. What? Yes, we're going to overwrite. We are going to overwrite a blank disk with data. Again, yes, we are going to overwrite a blank disk with data. Wow, we're going to lose all 0 bytes of data on our blank disk. Oh no. Go for it. Looks like it's found our 2 partitions. This does. Destination disk is too small. Okay. Let's see if we can make it do the thing. Okay, device. Disk to disk clone. Source drive, 8 terabytes. Target drive, 160. Skip checking destination disk size for creating partition table, because I mean the partition table is partition table comes out to like less than 100 gigabytes on the source drive now, so it should comfortably fit within 160 gigs. So, skip checking, repairing, use a partition table from the source disk. Okay, let's see if this makes it happen. I know that I've taken a smaller drive and cloned it up to a much larger drive. But this is actually the first time I've taken a larger drive and cloned it down to a smaller drive. And it looks like things are happening. Yeah, sure, it copied 349.2 megabytes in 2 seconds. And then, of course, you can see that if you were paying close attention, you could see that whenever it did the sync, it took a little bit longer. So, you see, I was definitely just dumping data into the cache on the target disk, which compared to the actual data that was being transferred was pretty deep. But I know these smaller laptop drives don't have particularly deep caches, so either I might just let this run to completion on camera, or I might turn the radio back. How about both? Yeah, so I'm either going to let, I might let this run to completion on camera. In fact, I'll probably do that in case it blows up in some new and interesting way that nobody's ever seen before. I don't know what that black box that just appeared in the middle of your screen, that was from the mouse cursor moving. I don't know what it is, but last like today and yesterday, I've seen screensavers randomly deactivating because the mouse moves. And I don't get how many, I don't know precisely how many pixels it's moving. I know X screensavers default mouse movement hysteria setting is 20 pixels. So, and I don't know of anything that's happening around here that would cause a mouse to move 20 pixels. But after this completes, I'm going to make sure that it'll actually boot up off of the new boot drive, and then we'll head over to my main workstation and configure everything via a terminal and screen recording. And I actually did decide to go ahead and dig up that camera. Syncing. And if you don't know what syncing is, synchronizing in terms of hard disks and whatnot, basically what that means is it flushes all of the caches. It flushes all of the disk caches out. No volume group was found. Basically what that means is it flushes the caches to the disks, and so basically what that does is it causes the basically the there's a separate boot partition. I'm trying to read output here and interpret what it means and talk at the same time, and it's just not working. Okay, update initial RAM file system. Basically, what I'm trying to say is, whenever you basically sync all your disks, what that does is it flushes all of the caches to the actual spinning storage, because the cache is just really high-speed solid-state media, such as DRAM, or it could be in a solid-state hybrid drive, or in a solid-state hard drive, or a solid-state hybrid drive, or just a hybrid drive, where you might have actual NAND cache, and basically what it does is whenever you tell the drive to sync, is it actually writes, all of the data in the cache out to the actual storage itself, whether it be NAND or spinning platters or tape or whatever the storage medium in question is, and that makes sure that all of the data that makes sure that all of the data that was in the cache is actually committed to storage. And so that means you can safely unmount the file systems or power the system down or anything like that without having to worry about data loss. So, now syncing flush file system buffers. Okay, well, it doesn't look like anything massively exploded, so let's reboot. If you work with Clonezilla long enough, you'll see plenty of references to synchronizing and flushing and caches and whatnot. Tries to be as safe as possible. Okay, let's boot from the WD 1600 BVT drive, which is 160 gig Western Digital Scorpio drive. Beep. Okay, we have grub. You see that the drive identifier has changed, which is a good sign. I do not hear the 8 terabyte drive just grinding away in there, but I do see activity, and the system is up. I know you didn't see any of that because the exposure is way too far down. So, let's see, numlock on. Turn the light on here so I can see the keyboard. Let's do that so that way I can get something full screen and okay. Yeah, everything looks good here. Sudo ZFS list. And I think we're all good here. So next steps will be, well, let's see, do we have network connectivity? Speed test. Yeah, it looks like it. Hosted by Nitel. 880 down, 814 up. Okay, yep, so we definitely have internet connectivity. Is DNS working properly? Ping .net. Yep. Alrighty, it looks like now at this point we can log out, head over to my main workstation system, and keep configuring. Okay, we are back. So yeah, turns out the 8 terabyte drive wasn't actually needed because I shut the system down, disconnected it, booted it back up, came back up fine. So I plugged it back in, booted into Mozilla just so I could get some sort of a terminal. And then I erased the first 8 megabytes of the disk, and that was that. Booted back up, and somewhere along the way, the Intel Matrix Storage Manager thought that one of the SSDs had, shall we say, gone catatonic. So yeah, it's trying to do a recovery here. It is online because we do a ZFS list. Everything's there, and that is yes. I mean, we know that we know that everything's here. See, I don't quite know what exploded there, but it obviously managed to unexplode itself because here we are. So anyways, so I'm just going to do an fdisk here, find out exactly what drive it is. SSD, SDC, SDB, SDA. So that's where we want to create our target here. This is a target drive for our new, what will eventually become our new ZFS data drive. So, before we do that, clear the screen, open up another pane. Root. Oh, that's right. I actually need to go ahead and mount that disk. Okay, that's online now. So now we can do a zpool get all v3 and pipe this to our pager. zpool create. Zpool create data. Show. Tons of stuff on locals. Okay, that's for the Z pool. There we go. Type that through our pager here. Type is obviously a file system. Create data O. Record size file. Okay. Extended attributes or system attributes. I'm not gonna enable deduplication just yet, because once I create this zpool, I'm gonna create another. Basically another zvol volume on the SSDs, and attach that to this zpool for deduplication. So here. Let's see where I want to mount. Where I want the mount point for that. So we got mount, and then let's make the data. Everything's on my boot here, obviously. Set that to be world readable and writable for everything just for now. I cannot open. Okay, I don't know what it's trying to do here. Okay, let's try this instead. So data, and then we will specify devSDA. devSDA contains a corrupt primary EFI label. You know, just erase the first 8 megabytes of the disk. So force it. And now zpool list data DD3 and special. So now we have some options to set on DD3. So we will go, let me see, ZFS set record size 512K on data. Set compression equals ZSTD on data. Extended attributes, system attributes on data, and set now point data. So where's data getting mounted at? CFH. Data is mounted at data. 7.1 terabytes free. Cool. Okay. So now that we've got most of our options set, fast list. Now what we will do is we will do a ZFS or Z pool create. Volume size, let's go 40 gigabytes. DT2. Okay, not Z pool. ZFS, create 40 gigs. Special DDT2. Now we have DDT2. Now we can add, let's do, find out what DDT2 is getting mapped as. Dev ZD16, 40 gigabytes. So, here, quit. Alright. Pool add. Dedupe Z16. And once I run this command, this pretty much becomes a permanent part of the Z pool whenever I run this command, because this holds the deduplication table, and I don't have any data written. I don't have deduplication turned on, so it's not like 100% permanent. But basically, once I add this deduplication volume, and turn on deduplication in the pool settings, this pretty much becomes a permanent part of the pool, because if there is a deduplication table present and that deduplication table gets sunk, then that's the end of the pool right there, folks. So go ahead and add. And it looks like it completed. DFS list. And now we will go to DFS set. Dedupe equals on data. And there we go. Now, let me see. How's our SSDs doing? 91.8% complete. There we go. 92.2% complete and continually ticking along. So now what I'm going to do is I am going to go ahead and attach I'm going to go ahead and attach the backup drive to the file server and get everything set up so I can copy everything back over, and go ahead and do that. Make sure all my mount points and directories are squared away, and we should go ahead and wrap this thing up pretty soon. Okay, we are back. Everything has been copied back onto the file server. And let's just kind of look at some statistics here as far as deduplication and compression goes. So we'll do a ZFS get compress ratio, and then give it the name of the Z pool, in this case data. And we have a 1.19x compression ratio. And if we just do a ZFS list data, actually a Z pool list data, we can see that we have a 2.03x deduplication ratio, and 1.82 terabytes in this Z pool has been allocated. So if we run the math on this, and we can do this first by reversing the compression, so 1.82 terabytes times 1.19, because what ZFS does is the first thing it does is it deduplicates the data, and then the deduplicated data gets compressed and written to disk. So we're kind of working backwards here. We have to uncompress it, and then we have to undeduplicate it. So 2.166 terabytes of uncompressed data. And then if we multiply in our deduplication ratio, that means that we have about, call it 4.4 terabytes of actual unprocessed data that was copied in. So that's a pretty nice savings there. Now, let me see, 1.9 plus 2.03 is 3.22, so 2.22. If we multiply 1.82 by 2.22, we get 4.0404 terabytes, which isn't right. And the reason being, these have to go in a certain order. You can't just put these any which way. So, anyways, so that's just some general statistics on the Z pool and what the compression and everything did. So what the next thing we're going to do is we are actually going to go ahead and convert the file system drive over to BTRFS, because BTRFS supports online deduplication, not deduplication, it supports online compression, and it somewhat indirectly supports deduplication, but you have to use a third-party utility called Bees to make this happen. So yeah, there's that. So we're going to go ahead and convert the external backup drive over to, oh look, there's my OBS recording statistics. We can just kick that off over here. So yeah, we're going to go ahead and convert the backup drive over to BTRFS. And so what we're going to do is do an fdisk L, and let me see, mapper 3. It's the third data disk. There we go. That's the file server drive. LSB OK. Okay, devmapper.fsb is an encrypted partition mounted over in the /mnt or mount directory on the file system. So the first thing we're going to do here is we're just going to go ahead and unmount it entirely. And then this is the slightly scary part, because this is our backup drive that we're working with. We see SDE 7.3 terabytes, SDE1, and then file server backup. So the next thing we're going to have to do is we are going to actually have to create the file system here, and we're going to overwrite everything. We're going to just steamroll this right over top of the existing file system. So, set the label to that. And then option free space tree for I forget exactly what that does, but it's also known as a space cache v2, and I believe it's a faster and more efficient way of allocating space on a BTRFS file system. And I'm not going to specify the force flag yet, and then I'm going to tell it where this file system needs to go, and we don't have that command on this system apparently. Okay. Yep. You know what, I probably ought to go ahead and throw comp size on here as well. Oh look, now we have to generate kernel images. And BTRFS comp size. Okay, so now that we actually have our BTRFS programs installed on the system, we can try this again. Unrecognized file system feature free space tree. Okay, probably because this is a Debian 11. Let me see this. Yeah, this is a Debian 11 system, so probably not running a new enough version of BTRFS for Space Cache v2. So that's fine. Just trim that option out, and appears to contain an existing ext4 file system. Alright, we did expect that. And let me see. Just mount. Make sure that this isn't actually mounted anywhere. And does not appear to be. Let's see. Contains an existing file system, and we will now use the F option to force an overwrite. And here we go. And there she is. So now we can mount mount directory and see that there's nothing there anymore because it's a brand new file system. So now I know you can enabling online compression in BTRFS has to be done at mount time with a specific mount option, and let me see. Yeah, there we go. So now we want to unmount. Let's see, target is busy. Okay. There we go. And now we will mount our newly created BTRFS file system to the mount directory, and then specify the option press ZSTD, and there we go. File system is now mounted with compression enabled. And so now I am going to stop recording and get bees installed on this system, and I'll actually go ahead and get that started up on the video, and then once I've got that started up, probably go ahead and stop the recording again and start copying everything back onto that drive. So now I need to figure out how to position this camera and my chair so everything works together, and I'm not seeing the blind side. I'm not seeing the blind half of the camera. And that was a wonderful noise, and I hope y'all don't have vertigo. I might as well just go and cut this section out, maybe splice it in as a blooper reel. Anyways. Okay, that's better. Reminds me of the view that I had whenever I was disassembling that failed Seagate ST 41650N hard drive. So, I'll lower the camera down here.